Hello everybody, and welcome to the very first video of our linear algebra course this semester. So in this first section, we'll be talking about some preliminaries, some tools that we'll be using throughout the semester. And in particular, in section 1.0, we'll be talking about matrices and matrix operations. I think you'll find that some of this material is familiar to you. You've seen it maybe in earlier courses. Well, there will be other things that will be new. Okay, so let's get started by looking at definition 1.0.1 here. Okay, so this is about matrices. So an M by N matrix A is a rectangular array having M rows and N columns of scalars. Notice that the first number M is the number of rows and the second number N is the number of columns. Okay, and we want to introduce one piece of notation here. So the notation A sub ij refers to an entry in our matrix. In particular, it's the entry that's in the ith row and the jth column of A. It's convenient to have a notation that lets us talk about that. Okay, notice again that the first number I refers to row position and the second number j refers to column position. Okay, so easiest way to get used to this notation is just to look at an example. All right, so notice that in example 1, they give us three matrices, A, B, and C, and they're going to ask us to find a couple of things just to get used to this notation. So we'll start with part A here. They would like us to find A sub 1, 2. Okay, well again, that refers to the entry that's in the first row and the second column of A. Can we find that entry? Well, let's see. If we go up here to A, we've got the first row and the second column. That would be this entry right here, 3. Okay, so A12 is equal to 3. Then if we move on to B, now they'd like us to find A21. So now we're talking about the second row and the first column. That would be this entry right here. That's in the second row and the first column of A. Okay, and just keep going here. So what about B21? Okay, well now we're talking about the matrix B. So the second row and the first column there would be -1. Okay, and then we come to D, which is asking us for something a little bit different. It would like us to add two matrices together. Okay, so let's clear a little clutter away here before we do that. Okay, so how would we calculate B plus C? Well, let's write those two matrices out. So B looks like this, and C looks like this. How do we add two matrices? Well, you may remember having done this in previous courses. So to add two matrices together, we're just going to add corresponding components. Okay, so for example, we can take 0 plus 1. That's going to give us 1 for the entry in the upper left-hand corner. And then 4 plus -1, that's 3. And we just keep doing that. So -1 plus 3 is 2 in the lower left-hand corner, and then finally 1 plus 0 gives us 1. Okay, and so there's our result. So we can add two matrices together provided that they have the same size, the same number of rows and columns. Okay, moving on here, let's see. What about 3 times C? How would we calculate that? Okay, well there we're taking the number 3 and we're multiplying it by the matrix 1, -1, 3, 0. Okay, and multiplication by a scalar, that's kind of our name for a constant, is just taking that scalar 3 and multiplying it by each entry in our matrix. So we're going to get 3, -3, 9, and 0 if we complete that. And there's our result. Okay, and then finally, this last one, this may be new to a lot of you. What does that T mean, AT? Okay, well in words, that means the transpose of A. So we would read this A transpose. Okay, what is the transpose of a matrix? Well, if you haven't seen this before, the transpose of a matrix, let's write it out first. The transpose of a matrix just kind of takes the matrix and turns it on its side. So the rows in your matrix become the columns. So for example, the first row of the matrix we started with is 1, 3, -1. That's going to become our first column. And then the second row is going to become the second column. Okay, so 2, -4, 5. So this matrix that we just came up with here, that's the transpose of A. Okay, we can make kind of an interesting observation with that. Okay, just kind of on the end of that calculation that we did. Okay, notice, for example, that, actually, let's see. I'm going to clear a little bit of clutter away. Just it's going to make it easier to do this calculation if we don't have all these things circled here. Okay, so let's see. What did we have here? 1, 3, -1, 2, -4, and 5. Okay, I want to pick on a couple of entries in the matrix. So, for example, A1, 2. Okay, that's the entry in the first row and the second column of A. That's the 3 that we've got here. And we could ask the question, where does that 3 end up in our transposed matrix? Well, it ends up right there, and notice that that's in the second row and the first column. So that's, if we look at the transpose matrix, the second row and the first column, notice that over here we have 1, 2, and over here we have 2, 1. Those positions reverse themselves. And this works for any entry. Let's just try another experiment. If we start with A2, 1, that would be the entry in the second row in the first column. Where did that 2 end up? It ended up here. That's in the first row and the second column of the transpose matrix. Okay, so in general, what we could say is that Aij equals A transpose Ji. That's really just another way of saying that in the transpose matrix, the rows of our first matrix become the columns. Okay, and that concludes our first video. We will pull all of this together into a couple of definitions in the next video.